Okay, so good evening once again, and welcome to today's and the first presentation that I'm going to have with you on Zoom, and in mathematics in particular, we're going to look at our simultaneous equations. Now, like the way I'd said, that simultaneous equation, simultaneous equations, we use quite a number of methods. We have for you, there are three, but I just teach two. But we have quite a lot of them. So we have methods. One, we have substitution. Two, we have elimination method. And then three, we have what we call graphical. All these are methods. Quite a number of them, but looking at the mathematics that you do, we will just have to look at those three. Though we might not even go and look at this one. This one, we might not even look at it. Yeah, because the graphical part isn't really much of great importance. So I might not even talk about this. I might just talk about two rather. And above all I can say is that there are distinct features that you follow when you are solving a simultaneous equation. At times, the nature of the question that you're going to have, will guide you which method that you can go for. Yeah, the method that the question, the way it comes, will guide you on which method that you need to go for. So quite interesting that we're just going to think one method today for all those questions that I have solved. Okay.
Yes, sir.
So the first method that we're going to look at is the elimination method. And I remember what I had given you. What I said was for you to use elimination method, you need to have three things that must be present. Three things that must be present. So I was saying for elimination method, we consider three things. Which things are they? Number one, you need to make sure that we have same variable. And understanding very well that a variable can be X, a variable can be Y, a variable can be Z, a variable can be any letters, yeah. And then the other thing that we look at is that for you to eliminate, there must be some same coefficient. When you say we've got a variable which is X and a variable which is X, if the coefficient must be the same, supposed to have a 4, If not for any number that you have, if the number that you have here is If the number that we have here is 6, even the other variable should have 6. That is what it means. That is what we mean by same coefficient.
So may you please repeat?
Okay, what I'm saying is that the other condition that we have to consider is that the part that you want to eliminate, they must have the same variable, which I said. If the variable is x, you must have my x ability. I'll explain how. If the variable is y, we're supposed to have my y ability. I'll still explain on that part. Now, the other thing is we're supposed to have the same coefficient. Now, what is a coefficient? A coefficient is a number that is written before a variable. So let's say we have the same variable x and x here and x here. So for us to qualify this condition here, we must make sure that the number that is written before the variable, that number must be the same. That's what the point is talking about. Okay, I will explain on how to verify. Then the other one is that the point that we want to eliminate, must have the third one, the signs. A sign might be a plus, might be a minus. The signs must be different. So in those coefficients, if the coefficient is 6, the other coefficient is 6, we have to make sure that the signs must be different. That is what that part means. Now, let me show you an example. An example of those questions that I gave you, and then we see how we can verify. We can verify these steps that we have. Okay, so the first example that we're going to look at is this one here. Where are you? We're going to look at this one here. So I won't really write the whole lot of the question. I will just have to explain, or maybe I can write for the sake of confidential, sake of transparency. So we're going to say example, question 1. Again, say solve the following simultaneous EOUS equations below. So that is the question that we have, and then let's look at how we can. That is a statement. Now, what questions do we have? That is a statement, but what question do we have? Question number 1 says that. So A, the question says 3x minus y is equal to 5. Then we have a little bit of space. We say 2x plus y is equal to 10. That is a question that we have now. Let us see how we can work around that question. That is A. And then I'll be adding B, I'll be adding C, just like that. This is our A. Now look at the way the question is. Look at the way the question is. How do we go about it? We are going to verify that information that we were looking for. And the information was that the first thing that we need to do is to make sure that the part we want to eliminate, they must have the same variable. Or maybe let me write the condition here. Okay, let me write the condition here. Okay, let me write the condition here. So say condition. Condition number one, we said it must be same variable. Then two, we must have same coefficient, same variables, same coefficients. And then the last one is that there must be different signs. Okay. If we say different signs, one must be positive, then the other one must be negative. That's what we mean. Now let's consider, maybe let me change the color of these signs here, put them in blue. Okay. Now let us consider this question that we have right over here. Let's consider this question that we have right over here. Can you see now, when you say these conditions, we are talking about a vertical arrangement. We're talking about a vertical arrangement. So let us verify on this part here. Do we have the same variables? The answer is yes. We have X on top, we have X at the bottom. The variables are the same. Now let us look at coefficients. Are they the same? On X, the coefficients are different because the coefficient here is 3, the coefficient here is 2. So they are different. We cannot eliminate. That one is refused. Let's go for Y variable. The Y variable here, is very true because for Y, the variable we have here is Y, so we have the same variable. Let's consider the other one. What coefficient we have? If you check nicely here, the coefficient is 1 and the coefficient here is 1. So the coefficients have also agree. What about the signs? Are they same or they different? The condition tells us that the signs must be different, and for sure here the signs are different. One is positive, then the other one is negative. Therefore, the part that only agrees to this condition, the part that agrees to this condition is this part that I have circled. Therefore, this is a part that you are going to eliminate. Evelyn.
Yes, sir.
Do you understand how I've explained?
Yes.
So once we eliminate them that way, then we're going to add in the vertical way. We need to add. And once we add them in a vertical way, we're going to say, what is 3x plus 2x? What is 2x plus 3x?
2x plus 3x.
Yes. My x yari 5, my x yari ya 3, tofakapo my x ya 2. How many are they going to be?
Sorry, sir.
I'm trying to solve this part. My x, the x's are 3. We add my x, then we add 2 x variables. How many are we going to have in total?
5.
Yes, so we are going to have 5x. Everything here has been eliminated. The only thing that we're going to do is to keep one equal sign. Then we are going to add the other things that we have after the equal sign. It's the numbers. So 5 plus 10?
15.
So we're going to have 15. Therefore, we are going to say that 5x is equal to 15. Now, once we reach this point, we need, now when they solve the simultaneous equation, they're asking you to solve for x, you also solve for y. So from here, we can solve for x by dividing by 5. We also divide here by 5. So at the moment this part cancels, we're going to say x is equal to, how many times can 5 go into 15?
3.
So the value of x is a 3. Very, very simple if you understand these conditions. These conditions are very, very important. Now, a lot of people have left this question just after solving for one variable. Now, you need to be reminded that this question carries 3 marks. Each year the question comes. 3 marks. Now, how do those marks get distributed? If you only solve for one variable, my friend, just know that you only have 1 mark. The other variable is the one that carries 2 marks. So it's important that you take the question to completion. How do you do that? We are going to substitute. Remember, they've told us that where there's x, the number which is there is 3. So we are going to rub this part so that we get the original equations. We are going to pick only one equation. We can have this one as equation 1. And we can have this one as equation 2. So pick one equation that you think you can deal with. Equation 1 or equation 2?
Equation 1.
Okay. So we're going to get equation 1, and our equation 1 says 3x minus y is equal to 5. Okay, so what do? We are going to, where there is x, we're going to put 3. So we're going to say, maybe let me change color. Let me change color here. So we are going to say that where there is x, we're going to put this 3. So we multiply, then minus y is equal to 5. And then we're going to say that 3 times 3 will give us 6, minus y is equal to 5. Okay, so once we reach here, there are 2 methods that you can follow. If, by the way, we are collecting the like terms. Now, when collecting the like terms, if you want, either you take this one that side, and this one comes this side, or if you don't want that way, it's better you just take this one the other side. So the one that I feel is much better, so that we don't get confused with the signs, it's better we follow this method. So remember, we have a 6 here, we have a 6 here, we have a 6. When this 5, which is positive, comes here, it's gonna be 5. But why are we doing this? This guy doesn't have a variable, this guy doesn't have a variable, so we put them together. And once that happens, we're going to have an equal sign here, which will be here. And this y, which is negative, goes there, it becomes positive. And here we are subtracting 6 minus 5 will give us y. 1 is equal to y. So we are saying that the value of y is equal to 1. As simple as that. So that means you have solved for both the x variable as well as the y variable. You have solved the simultaneous equations. Any question from what we've done?
So I have a question.
Yes, you can ask.
Sir, why did
Yes.
you put this other 3 in brackets? I didn't get the point.
Okay, so the way mathematics is when you, let me do this. I'm just going to hide, and then later on, I'm going to unfold. I'm going to hide this part. The way mathematics is, okay, maybe let me not do, oops, let me not go that far. Let me just put this part. The way mathematics is, my friend, is this. If you have a variable which says 3x, it means we are multiplying 3 and what number? The number that is represented by x. That is what mathematics means. Oh, you cannot see, but me, I can see from my tablet here. Okay, so just allow me. Okay, that's what I was trying to do. Okay, you see that?
Yes, sir.
When they say 3x, they are saying 3 must be multiplied with a number which is hidden, but they have just put a letter x. And now from our experimental finding here, from our numerical finding, we said where there is x, what we have is a 3. That's why where there was x, we forced ourselves to put a 3 so that we multiply them. Beta, if you don't want to go by that method, right over here, you can just say 3 multiplied by 3. It is just one and the same. The key thing there is that we must multiply them.
Yes, sir.
Any question?
No, sir.
So we can go to the next one.
Yes, sir.
Good. I'm going to keep whatever I'd written here on ink so that we don't really waste time writing things every now and then. So I'm going to remove this part here, and then I get my rubber, move this, I remove that, I remove that. Okay. This was question A. Now let's see question B right over there. Question B, where are you? Let me just look for it. Question B is here. Question B is, which one have we solved now? We did this. So we started with this one. I've not done this. Okay, this one. Okay, the other one says, so B, oh, not white. Let me put blue now. Okay, not blue, black. Okay, so the B says that 2x minus y is equal to 5, and then x plus y is equal to 4. That is our question B. Now, if you look at the question B over there, we can see some similarities between question A and question B. Can you see that they're somehow similar?
Yes.
Which part is similar if you are seeing what I'm seeing?
There's different signs.
Oh, the part that we eliminated in the first question, isn't it?
Yes.
Yes. So the same conditions that we had here, the same conditions that we had here are the same that we had here are the same conditions that we have even on the new question. So that means the same way in which we eliminated this part is the same way we are going to eliminate even this other part. It is just the same way we are going to eliminate. Why are we eliminating? Because if you confirm same variable, we've got y, same coefficient, we've got 1, 1, and it's different signs, we already have them. So that means that middle part we're going to eliminate, and elimination means that, remember, this is equation 1, and that is equation 2. And once we do that, we're going to add them. We're going to add them, and once we add them, we're going to say what is 2x plus x?
2x.
Sorry?
3x.
3x, so we're going to say 3x is equal to what is 4 plus 5?
9. It's 4 plus 5. Oh, 9.
Okay, so we're going to have 9, and then we write the 9 right over here. So what do we do to find, so for x?
We're going to divide by 3.
We divide by 3 here. We also divide by 3. So we say how many times can 3 get divided into 9?
3 times.
We'll go in 3 times, so therefore the value of x is 3. The same thing that we did, then we're going to get any of the equation here and solve for y. Remember, we've just gotten ourselves 1 mark. We need to defend the other 2 marks. So because in the previous question we used equation 1, this time around we're going to use equation 2. So we're saying x plus y is equal to 4. What does it mean? They're saying where there is x, what do we have? We have a 3 plus y is equal to 4. Can you finish it up?
We're going to take the 3 to the right side where there's the 4.
So we're going to have y is equal to 4 minus 3. What is the value of y?
1.
The value of y is 1. So as simple as that. Now you see, the beauty of going through different questions is that you get exposed to real material. You get exposed to many, many, many questions. This one here came in 2014. Oh, okay. This one here came in 2014. This one, 2014, paper 1. And then this one came in 2016. And you can see that they just changed the questions, but the answers are just the same. The first one, we had x is equal to 3, y is equal to 1. The second one also that we are doing, we have x, 3, and y is equal to 1. So it is very, very, very important that we understand we go through as many questions as we can, so that that day, even when they repeat the same question, we'll have an idea on how those questions were solved. It is very important, and that's why most of the times when I'm teaching, I like giving you questions from past papers, because they help us getting to know how questions come and how we can make use of them.
Okay, sir.
So let us look at a different question. Okay, so a different question will be somehow a little bit different from what we've done. And then we're going to see how best we can go about it. Okay, this one here, I'll make it question number C. question number C. So question number C, allow me to use blue now. Question number C, we've got 3x minus 2y, which is equated to 12. Then the other one says x plus 3y. And then the answer is equated to -7. Now, if you look at the way this question is, there's quite a lot of some differences in that, oh, not that one there. Oops, I think I've made a mistake. Oh no, the bad part of it is that I just have to go back. What if I do this and then I just get to know that whatever here is a plus. Yes, whatever is a plus, than typing everything. So if you look at the way this question has come, there is no part where on the X party or on the Y part where all the conditions are the same. There is nothing like that. There's one part where only one condition is met, the other part where. So we need to have a combined effort. Now, look at the X variable, the part for the X variable, we've got X here, we've got X here. The coefficients are different. On the variables are the same, the coefficients are different. Let's go for Y. Y, we've got same variable, which is okay. We've got different signs, which is okay. But the coefficients are not the same. So now, how do you get to solve when the coefficients are different? So for different coefficients, all you need to do is to swap those coefficients. Interchange the coefficients. Interchange the coefficients and then multiply. Multiply with the entire equations. These are the first things that you need to do. That is how you're supposed to do. You tell me if you have written it down.
I'm writing, sir.
You are writing?
Yes. I'm done. I'm done, sir. Okay, move on.
Okay. So we need now to get to solve. Okay, how do we go about it? So let's see how we can go about this. So we are saying that thing here must be a plus. We are going to interchange the coefficients. For equation 1, the coefficient that we have is a 2. Do not consider the signs because the signs have their own way in which they are dealt with, okay? So the coefficient, do not say the coefficient is -2. Just pick it, the 2 as it is. Ye kachabe. Then on the part for the other equation, the coefficient is 3. After you do that, then you multiply with the entire equations. So you're going to multiply this 2 with the 3, this 2 with the 2. No, I've not swapped them. Sorry, I have not interchanged them. The interchanging has to be done that this 2 which is here must be multiplied with the other equation. Then this 3 which is there must be multiplied with the other equation. That is the interchanging I'm talking about. So that when we multiply, we're going to have 3 times 3x. We're going to have 9x. We have a negative sign. 3 times 2, we're going to have 6y is equal to 3 times 12, we're going to have 36. After that part is done, then we say 2 times x, we're going to have 2x plus 2 times 3, we're going to have 6 y equal to 2 times -7 will give us -14. So once you've done that, once you've just swapped the coefficients, and then you multiply them, you will find that this part will definitely be eliminatable. Have you seen that part? We can see that variables are the same. Oh, sorry. We can see that the y variables are just the same. We can see that the coefficients are also the same, and the signs are different. So from there, we can eliminate. And once we eliminate, we are going to add the rest of the numbers in this way. So what is 9x plus 2x?
11x.
So we're going to say 11x is equal to 36 minus 14. We're going to have 22. And what do we do to find the value of x?
So you said 36 minus 14.
Because even if there's a plus here, the overall sign will be a negative, so we need to subtract. So what do we do to find the value of x? How much time are we
going to divide?
So we're going to do, only 1 minute. Let's be a little bit fast. We divide by 11, we divide by 11, and x is gonna be 2. Once you do that, you get and substitute it in the original equation. So we had x